Hello everyone, you're welcome to Biology Lectures with Akirili Olademeji Philip. On today's edition, we're looking at vaccination, which is one of the sections of communicable diseases. All right, now looking at this very illustration on this very page, you'll be able to see the fact that a fetus is being engulfed by a bubble, like he's being protected, so to say. You can see that here now, that this is a bubble coming from injection to this fetus. Now the thing is, that bubble seems like a protection against the what? Against microbes. So you have microbes all over this baby. So it's some sort of protection that a child gets from, to prevent that child from getting sick much later in future. That's just like a brief summary of what vaccination means. So let's move on into the lecture. Now, vaccine, which is the chemical that will be used to bring about vaccination, allows a dead or altered form of the disease-causing pathogen. Now, the Article D means that you're being specific. You're referring to a particular disease. For example, let's say I'm referring to polio. All right. Now, so it's not just, anything. It has to be specific. Say the form of which means a particular microorganism that causes a disease, which contains a specific antigen to be introduced into the body. This causes the immune system, specifically the white blood cells, to produce complementary antibodies. Now let me explain what that means in a minute. Now it means that, for example, if you have you are being given vaccine for polio, it means you are being given the dead form or altered form of polio, so to say. Now, because it is dead or altered form, it will not cause the poliomyelitis itself. However, because of its presence, it will stimulate the immune system to build antibodies specifically for what? For polio. So that when the real polio comes much later in the future, when the real polio pathogen comes much later in the future, there's already enough antibodies to kill it, or the immune system will quickly reproduce enough antibodies through the effect of memory cells, which I'm going to explain much later. All right, so let's move on. You're going to get that as we move on. Now, the point is, as good as vaccination is, our parents have to give their consent. So to decide whether to give vaccine to a child, it will be done by the decision will be made by the parents, because the child that will take the vaccine can't take this decision. All right. Now, there's a risk associated with any injection, which means people get scared of being infected by injection, or people get scared of the pain and all of that. But the point is, the pain you get from being pricked by injection is not enough as when you get a disease, so it's better to endure the pain. All right. Now, immunization or immunizing, which is the same thing like vaccination, increases herd immunity. I'm going to explain this much later, but let me give you a explanation now. Herd immunity simply means some people that are unable to get vaccines will be protected from a disease because other people around them have been vaccinated. I will say that again. Herd immunity means that people that are unable to get vaccines or get vaccination will be protected because people around them were able to get vaccines. I'm going to explain that much later. Now, it says here that is those who are unable to be vaccinated are protected as outbreaks of disease are prevented because others have been vaccinated and therefore immune. So it means that, imagine in your house, in your home, you have 6 of you in the house, and you have 4 people are vaccinated against, let's say, COVID. That means when they go out, they can't contact the disease. Even if they contact it, it's going to die in them. So which means there's lesser chances of them bringing that home. So it means the chances that the 2 people in the house that do not get vaccines from getting the disease will reduce. Don't worry, you're going to understand that much later as we move on. Now, so consequently, vaccine reduces the likelihood that an infected individual will spread the pathogen they have they have been vaccinated against to others. That means that once you've been vaccinated, you can't definitely transfer that disease to somebody else. All right. Now, if a large number of the population are vaccinated, it is unlikely that an unvaccinated individual will become infected with the pathogen. That's clear. Imagine that we have about 66 million, about that number in the UK, and about 50 million have been vaccinated against COVID. That means we only have 10 million that are not vaccinated. So the chances that those 10 million will have the disease has reduced. That's also explaining herd immunity. Now, there are three scenarios with vaccination, which are, the first one says there are no vaccination and the disease spreads quickly. That explains why COVID kept spreading. All right. Now, some of the population are vaccinated and the disease spreads to less people. So it means that the more people are vaccinated, the lesser the disease spread. Now, it says here, most of the population are vaccinated and this prevents the spread. Like, you're going to see that as we move on when you get to herd immunity. All right. Now, this is what I was explaining. I want you to just follow this. This is very, very important. Now, you see that we have, let's say we have group, let me label this as our group A. This is group B and C. Now, you can see the key here. It says that this, let me say this is blue. This first one, this blue, means they are not vaccinated, but they are still healthy. All right. Then this green says they are vaccinated and healthy. Then this last one says, the red says that not vaccinated, sick and contagious, which means they can transfer it. Now, let's see what happens. So this first group here, group A, we have just two people that are sick, no vaccine, and they are sick. So you can see what happens here. It says here, no one is vaccinated. So contagious disease spread through the population. See what happened. Because nobody was vaccinated. Within the space of, I don't know how long, initially, in the beginning, we have two people that had the disease. Now, see what happened after some time. We have three, like we have, that's 6, 9, and 10. So within the space of, so we have how many people? Let me count that again. We have 6, that's 18. So initially we have two people being affected, so 16 were healthy. But without vaccination, 10 people became infected, and only 8 people became, only 8 people still remains healthy. So let's see what happens in group 2. Now in group 2, we have the green. 1, 2, 3, 4. They were vaccinated out of 16 people. See what happens. So it says here, some of the population gets vaccinated. Now, the contagious disease spreads, through some of the population. Now, see what happens now. So, those ones that are vaccinated, obviously will not get the disease. They still remain like that. But now, see that the people that were infected are just 2, 3, 4, 5, 6, 7. So, only 7 people got the disease now because some people have been vaccinated. So let's move on. Now, at this group C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 people got vaccines. So it says here most of the population gets vaccinated. Now, spread of contagious disease is contained. See what happened. Only 2 people got the disease because most of the population has been vaccinated. So which means that herd immunity protects the vulnerable that may not be able to have vaccine indirectly. So for example, now there's some people that cannot get vaccines. Probably they're a bit allergic to some things, or they have a poor immune system, or they have issues with their body, so they can't get vaccine. But once people around them have been vaccinated, they also will be protected because they might likely, the chances of getting that disease has reduced. That is herd immunity. Don't forget that, it's very important. Herd immunity is an indirect protection that people that could not get vaccine get when people around them have been vaccinated. All right, that's more like it. So let's move on. So of course, I think most of the things you've seen on this page just further explains what I said earlier on. It says here, vaccination will prevent illness in an individual by providing artificial immunity. Now, most vaccination occur during childhood, so the decision whether or not to take vaccine falls on the parent. I think I explained that in the first few slides already. Now, vaccination involves exposing an individual to the antigen of a pathogen. Now, let me quickly say something here. This cell I'm drawing on the screen, let me take that here. Like, okay, this is a pathogen. Then on its surface, there are some structures there called antigen. So it means that we are going to sometimes scrape this or get this antigen on the surface of the pathogen and introduce that into the person's body. Once that is done, it will trigger an immune response, which will result in the formation of memory cells, which will make antibodies against it. Now, let me get that clear. What it means is this. I think I explained that earlier on. The moment you introduce an antibody, the antigen from a pathogen, in its inactive form, it will stimulate the body, the white blood cells, to produce antibodies, number one. Number two, it will stimulate some cells called memory cells that will always remember that one pathogen has been here before. Even though this vaccine was introduced in an active form, the body will still know that this guy is not part of us. So the body will still provide some sort of immunity, and the memory cell will still remember that this is not part of us. So when it comes back later in the future, the memory cells will just tell the antibodies, hello guys, this guy came some years ago, and I expected you guys to have formed antibodies against it. So now it's back. I want you guys to kill it. Literally, that's what happens indirectly. All right. Now, if a vaccinated individual is infected with the very pathogen for which they received vaccine, that means they've received vaccine before, they can destroy it before they become infectious. That's what happens. As a matter of fact, now let me be more practical. Let's imagine that you got vaccine for polio, and the vaccine was a dead polio pathogen, and your body was able to form immunity, develop antibodies, and memory cells have remembered what polio pathogen probably looks like. So the day the real polio pathogen, the active one, comes in, because the memory cells remember that it was here some years ago, even though in the form of vaccine, and the body has formed some sort of antibodies against polio specifically, within hours, all of the polio antibodies now will just come around and kill that polio virus or the pathogen within few hours. The only thing the person might just feel is just have some few fever. Just feel feverish for some few minutes. It might not be obvious. So before the polio pathogen reproduces, it has been dealt with by the body immune system. So let's move on. So moving on. So there's something we call worldwide vaccination, which talks about the effect of vaccination on the whole world, as it were. Now, the role of WHO, which is World Health Organization, is to monitor global diseases. They will track if a disease is endemic, epidemic, or pandemic. I'm very sure that this pandemic will sound more familiar because COVID-19 is actually a pandemic in itself, so that will sound more familiar, but I'm going to explain all of the three now. So what's the meaning of endemic? Endemic is a disease that is always or known for a particular group of people or for a particular race or for a particular ethnic group, so to say. For example, malaria in Nigeria or in Africa is an endemic disease, which means it is known to be in Africa for years. So it's there, like it's a common thing there. So when you hear word that disease is endemic, it means it's only found in that region alone, or mostly in that region. It's common in that region. COVID is not endemic in any way, it just came. But malaria is endemic in Africa because it is common there. Now, next one says epidemic. An epidemic is a disease that affects a large number of people within a community. Now, not only does it affect with people within the community. Now, listen to me now. Don't feel like, okay, saying what's the difference between endemic and epidemic. Now, the one of endemic is like it has come to stay. It's always there. it's always there, and it's only known for those people. But epidemic number one is like a sudden outbreak within a local region, like within a population. Let's say, for example, let's say one small village in Nigeria just have what's it called, cholera outbreak. Now it is an epidemic because it's just a sudden outbreak that affects a local place within a place. So epidemic and endemic both affect a local place, but epidemic is like a sudden outbreak. It was not there before, or maybe it was there then suddenly increased. But endemic is always there. There's no news about malaria anymore. Malaria it has come to stay in Africa, so there's no news about it. But epidemic simply means something just started all of a sudden. Then the last one says pandemic is an epidemic that spreads over multiple countries. What does that mean? So it means it's a disease it's an epidemic affecting different Nigeria, New Zealand, Turkey, Australia, everywhere. As it is now, COVID is a pandemic. It's also an epidemic because it's spreading, it's a sudden outbreak, but because it's happening at multiple places at the same time, that's why we call it pandemic. All right, so let's move on. Now, of course, this is just talking about, this table explains the different diseases that affected the human race or the world years back, and what happened when we began to introduce vaccine. You can see it here that diphtheria, of course, used to be this large, like 158 million thereabout, then reduced after getting vaccinated. When you say post-vaccination cases, it means after people have been vaccinated, it reduced totally. That's like 100% reduction. Look at measles, it reduced by 0.2%. That's like how much it has reduced. So that's like 99. The cases left is about 0.2. So it's like that's like 99.9 reduction. Mumps, of course, about only 222 million cases are left within those years of 1963 to 1968. So thereabout. Then that's about 97.4% reduction. You can see tetanus there. About 0.4 million is less. It's left to have the disease after vaccination. You can see smallpox here saying that we have 0 left within 1900 to 1949. Actually, by now I think this will have even reduced them more because vaccination has increased them. Is now more on the rise. Now these are just the different diseases I was mentioning. You can see mumps here. Mumps simply means a disease that affects the salivary gland. It causes it to swell up. It's caused by a virus, and it doesn't really have a cure, so to say. Probably just get used drug for the pain it causes. After sometimes it's expected to go, and it's not very deadly if I'm not mistaken. No, it's not. Now we can see smallpox there. You just have some rashes. Now smallpox is quite different from measles because it's the rashes is more to the face, unlike measles that is more to like the body, to the arm, the upper limb and lower limb, so to say. All right, you can see tetanus, which is a disease that causes the person to have some sort of convulsion, or let me say seizure, so to say. The person has some sort of jaw lock. You can see that there as a locked jaw, like the person's I'm trying to, let me see if I can show that out here now. Okay, like some sort of jaw lock. And see the person, sometimes they clench their teeth together. It can be that bad. You can see some sort of convulsion here from this man here. You can see this person down here showing some sort of convulsion there. All right, so moving on. So, and the last one talks about diphtheria, which is a disease that affects the throat. Like it causes the throat to swell up, some sort of you can see what happens here. Let me get out the pen to show you that. See what happens here. It can be so bad that the throat will swell, and this whitish stone will obstruct the throat, and the person will have difficulty in breathing. Now the good news is all of these diseases now has reduced so much that some of us doesn't even know they exist because vaccination has been given at childhood, even at adulthood, to protect us against these diseases now. All right, so how does vaccination or how does vaccines work? Now, vaccination involves introducing small quantity of dead or inactive form of a pathogen into the body to stimulate the white blood cells to produce antibodies. I think sincerely we've explained this in the previous slides, like really. Now, if the same pathogen re-enters re-enters the body, the white blood cells respond quickly to produce the correct antibodies, preventing the infection. That's clear. Then now, this is just like some sort of summary here now. Let me see if I can get that closer, okay? Number 1 says, harmless pathogen is being introduced or injected into our body. So we've introduced the pathogen like that. Check. The next thing happens is this antigen triggers an immune response. It can take days for lymphocytes to make complementary antibodies to be activated. So it means the name, let's say it was measles vaccine that was given. So the complementary antibodies here will also be for measles. All right, will be activated. Then number 3 says lymphocytes are able to produce complementary antibodies, multiplies antibodies release. So that happens when the body encounters that much later on. Let me get that out here now. Number 4 says memory cells, which can stay there for years. Memory cells are the ones that will remember when that pathogen comes back again. All right, they are produced if the antigen is encountered again. So antibodies are produced much faster. So the moment it comes back again, the memory cells quickly know that this guy has been here before, even though it was form of vaccine, and antibodies, we already have some antibodies already formed for it. Then more will be formed within few hours. Before that pathogen reproduces, enough antibody has been formed to get rid of it, and that will lead us to having a long-term immunity. All right, so let's move on. So you can see the process of long-term immunity by vaccination. So of course, this is just a graph showing us how the body responds to vaccine, so to say. It's a graph showing the number of measles antibodies in the blood following vaccination and infection. See what happens here. So this is what happens normally. This is the antibodies in the body like that. So when we get the vaccine in the person's body, what happened is, okay, the antibodies increased like that, then dropped. But there's something called memory cells that have marked it. The moment the real infection now comes in, see what happens. The antibodies just increase like a spike like that, and because of that, they will just deal with the measles virus within a short time. All right, so this is just a further explanation to what we have. Now, types of immunity. Basically, we have the active immunity, which comes from our body creating antibodies to a disease, either by exposure to the disease itself, which means you contact the disease. Let's say if you have measles for the first time, you contacted it by through the air or from somebody that has it. That's naturally because you contacted it itself, and of course once you're free from that measles for the first time, your body has formed antibodies against it, so you're not supposed to have measles again. So you have been vaccinated naturally, or by vaccination, which means you didn't contact measles virus itself, but you were given the dead form of measles virus. That's the artificial one, but either way it was active. Then the other one is passive immunity, which means that you get antibodies from another organism. In this case, the best one is from breast milk, which a child gets. So that's why it's always important that a child gets enough breast milk from the mother. It's very important because that's the only way the child builds immunity from childhood. So all the immune system of the mother has passed on to the child that way. To a large extent. Now, with measles vaccine, for example, vaccination with a weakened form of the measles virus results in the production of antibodies and memory cells. So when exposed to the virus naturally and infected, an individual can produce a higher concentration of antibodies much more quicker to destroy it. I believe this is quite clear. So lastly, what is the advantage and disadvantages of vaccination? Advantages include the fact that when the diseases that were once common are now fairly rare due to so let me read that again. Diseases that were once common are now fairly rare due to widespread vaccination. For example, polio and measles. Sincerely, here in Africa, polio has been one of those serious cases. But with the advent of vaccination over the years, over decades, it's almost like some people don't even know, some younger generation doesn't even know something called polio because you hardly see it around. All right. Now, but the disadvantage here is that sometimes vaccines might not work. That can be very funny. Sometimes it might not even give the immunity we tend to get. The next one says epidemics can be prevented if large number of the population are vaccinated. In a minute, can you quickly tell me what this means? I explained that. Can you just think a little? All right. I guess you said herd immunity. What you're saying here, it says epidemic can be prevented if large number of population are vaccinated. That's like some sort of herd immunity, HERD. All right. Now, what's another way to explain disadvantages of vaccination is there can be side effects to the vaccine. For example, swelling or a rash to more severe reactions such as seizures. For example, now I think about a month ago, I actually got yellow fever vaccine myself, and I was told to stay for about 30 minutes on the spot. Why? Because they felt I might have some reactions. So sometimes some people do get reactions after taking vaccines. Their immune response in a very harsh way. They have allergies and all of that. All right, I think that explains vaccination. Feel free to chat me up if you have any comment or any question. Thank you.